Okay, we're going to page 253 and page 254. This is talking about the surface area of the triangular prism, which we've just been doing the surface area of a rectangular prism. Okay, so it says draw and label one of the identical rectangular faces, then draw the third and find the area. Then it gives you all the different areas that it's doing. So these are what they drew. So this is going to be asking us to draw in the future. It says what formula was used to find the area of the faces. So that's this formula right here. So we can say area equals 1/2 base times height. What formula was used to find the rectangular faces? That's just base times height. Why is the area of the rectangle different from the area of the other two triangles? It's talking about how the rectangles are different sizes. So the area of one different from the area of the other two. One rectangle is different because if you look at the triangle, one side of the triangle is longer. See, this is 1 and 1, but this is 1.2 because one side of the triangle is longer. All right, we're on page 254. A manufacturer packages a product in a box shaped like this triangular prism with the height of 5 centimeters. Okay, height of 5 centimeters. The dimensions of the prism are shown. Draw each rectangular face of the box, label the dimensions, write the area in it. Okay, so if there's ever a prism, we know that there's going to be 3 rectangles. Okay, so we've got 3. And the height they said of all are 5. So I'm just going to put 5, 5, 5. Okay, and then on the side of each is going to go one of each of these. Okay, so 6.4, 8.0, 4.8. And how you find the area of a rectangle is always length times width or base times height. So we're just multiplying all of them. So 6.4 times 5 is 32. 8 times 5 is 40. 4.8 times 5 is 24. And then it says to basically write all of them, and that's all we had to do. So draw each of them and label the dimensions. Write the area of each rectangle inside of it. There's our areas. Awesome. All right, write and solve the equation to find the surface area of this problem previously. Okay, so if we're going through and we have the triangular bases, there's 2 of these in every prism. So let's find the area of this, then we'll have 2 of them. So base times height, that's 4.8 times 6.4 equals 30.72 divided by 2 equals 30.72 divided by 2 equals 15.36. Remember, there's 2 of them, so times 2 equals 30.72 again, makes sense. 30.72 plus, okay, now we've got all these 3 rectangles, so we have to add the 40, the 24, and the 32, plus 40, plus 24, plus 32. All right, plus 40, plus 24 plus 32 equals 126.72. So the equation 126.72 square centimeters. If the height of the box in problem 4 is doubled from 5 to 10, does the surface area double? So if these 5s turn into 10, Would the surface area double? Well, we would have to look at that. So basically, there's no shortcut around that. We would have to solve it. We'd have, what we got here was 1/2 base times height. So this would still look similar. We'd still have this part right here divided in half and then multiplied by 2. So we'd still have 30.72. That didn't change at all. But then when we're talking about the other heights, the 5, the 5, and the 5 becoming 10, that just means that this would be, if this was 10 times 8, that would be 80. And 10 times 6.4 is 64. And 10 times 4.8 is 48. So we'll be adding it like this. So let's see. 30.72 plus 80 plus 64 plus 48 equals 222.72. When I look at that, is it double this? So it's increased, but it's not double, because if you do 126 plus 126, you get like in their 250s, and it's not close enough, okay? The surface area is bigger, but does not double. Find an expression for the surface area of a cube with the length S. What's great about cubes is that every single part of it is exactly the same. So there's 6 pieces to a cube. If you ever did a cube net, you have 1, 2, 3, 4, 5, and then you've got the top of your cube, 6, and they're all the same. So if the edge of the length is S, you got 6S, and then it's times S again. So you could write 6S times S or 6S squared, and that would give you the exact same area. So equals area equals surface area of a cube. Surface area of a cube. All right, and we're gonna go on to 255. So you got 253, 254. Here's 255. It's the surface area of any complex solid. So what they did was they took the storage box and labeled all these different prisms and put them and made their own area for every single face, okay? Took these, took them apart, took this all apart, made them into all these different objects, and then found the area of each. So it's saying what is the surface area of the whole thing, which means please add all of these. So if we were to add all of them, that would be 150 plus 150 plus 972 plus 936 plus 108 plus 360 equals 2,676 square, 676 square inches. All right, that's huge. All right. Chris says that he can find the surface area faster by thinking of a box as a triangular prism on top of a rectangular prism. And then he finds the surface area and adds them together. Does that make sense? It doesn't, because they're combined together. You can't add one on top of each other or you'll have extra faces. So no, because you end up with extra sides and faces. Okay, you can't think of it as a triangle on top of a square because they're put together. There's no faces in between them. All right, on the back, Milo is making a set of blocks for childcare business. He has a block that is a triangular prism. He cuts the top off of it to make it then a rectangular prism. That's great, and he paints that red. The original triangle, what is the surface area that he paints red? So it's just asking you, here's the original, but we really want to know the surface area of the rectangle. So rectangle, it's like saying what you have right here, which would be just 6 times 4. 6 times 4 plus, oh, there's 2 of those. There's 2 of those faces. But the way that we're doing it here, you can just do 6 times 4. And then you're going to add, and then you have 2 of these. You have a 5 right here, and then you've got 5, oh, right here, 10.8 and 5. 2 of 5 times 10.8, and then you've got a 6 again and a 10.8. So plus 6 times 10.8, and you only have 1 of those. Okay, so we have 5 times 10 point, oops, 5 times 10.8 equals 54. We have to double it, times 2. To add 6.4. So that's this right here. We still have to do this part. I'm going to put 114.4 here. We have to add this part. So 10.8 times 6 was 64.8. If I add these together, 114.4 plus 64.8, I get 179.2. Hi, this was doubled. So we do 64.8 again. 179.2. Surface area is 179.2 square centimeters. All right. So we've got 179.2 square centimeters. It says to refer to problem 3. He paints the lower piece green. Draw one of these beautiful trapezoids and label the dimensions. What is the surface that he painted green? The area of a trapezoid is going to be taking the 1/2. There's still 2 of them, but it's now we're talking about more of the triangle part. So 2.5 times, and we have to cut this. So 2.5, 3 times 4.5 plus 6 times 4.5, which is 3 times 4.5 equals 13.5 divided by 2 times 2 brings it back to 13.5. So we've got 13.5 plus, and you got to do 6 times 4.5 equals 27. If you add those two together, plus 13.5 equals 40.5. Then to get the surface area, the hard part is that when this was just the trapezoid area, this was just the bases. So we've got, we got to take this and double it because that was only one base. So times 2 equals 81. So now we've got